This is another fun example that's a continuation of the previous example. Again, there's an animated graphic that accompanies this example that provides a nice visual of what's occurring. Again, a Ferris wheel can be thought of as a giant unit circle. So I have a unit circle here, and hopefully you'll see how this simple approach can answer these 4 problems here. So this problem states, the Ferris wheel at Pacific Park on the Santa Monica Pier in California has a diameter of 90 feet. Suppose friends Estefania and Nicole are riding the Ferris wheel when the wheel stops to let on more passengers. Mischievous Nicole decides to drop a marshmallow over the side of the car. So for A, it says, if the car the girls are riding has a central angle of 315 degrees from horizontal when the wheel stops, how far from where the passengers get on the wheel will the marshmallow land? So a couple of things to point out here. Again, the diameter of the Ferris wheel is 90 feet, so that means it's going to have a radius of 45 feet. And that's going to matter because it's going to help us with our distances. It also says that if the car the girls are riding has a central angle, the central angle is going to generate from our horizontal axes here. Also, it says when the wheel stops to let on more passengers, we're going to assume that when the wheel stops, it lets the passengers on right at the bottom here, right here. Also, we have to assume that the pier is right at the bottom of the Ferris wheel. So I'm just going to pen it in like that, make it a little wider. There we go. If the car the girls are riding has a central angle of 315 degrees, so 315 degrees comes in right about here. And as we've learned in the past, this is going to create a special right triangle, and that special right triangle is going to be a 45, 45, 90 right triangle. The difference between this example and the previous example is the girls are going to drop a marshmallow. And we have to assume that when they drop the marshmallow, if this is where their car is right here, when they drop the marshmallow, it's going to land right below it, right below where they drop it. So we're just going to say like right here. And we want to know how far from where the passengers get on the wheel will the marshmallow land. So we're looking for this distance over here. So of course, this is the distance that we're concerned with. And since this is a 45, 45, 90 special right triangle, this distance here is going to be the square root of 2 over 2. And of course, that's if this is the hypotenuse here, the radius here is 1 unit. And of course, we know that it's not. It's 45 feet, or 45 units, but 45 feet. So the distance from where the marshmallow lands to where the passengers get on, that's going to be 45 times the square root of 2 over 2. And of course, you can use your calculator. And if you plug that into your calculator, that winds up being approximately 31.82 feet. So that's the answer to A. So we'll try B. B says if the car the girls are riding has a central angle of 180 degrees from horizontal when the wheel stops, how far from where the passengers get on the wheel will the marshmallow land? So this is our 180 degrees right here. If they drop a marshmallow, it's going to land right below it. So how far is that from where the passengers get on? And what we've learned in the past, and visually we can see that it's going to be the length of the radius. So that's simply going to be 45 feet. So for B, that's 45 feet. Let's try C. If the car the girls are riding has a central angle of 135 degrees from horizontal when the wheel stops, How far from where the passengers get on the wheel will the marshmallow land? 135 degrees, that's up here. Again, we have another special right triangle. That's going to form our 45, 45, 90. If this is where the girls are riding and they drop a marshmallow, it lands right here. How far is that? Well, that's going to be the same distance as it was for the answer in letter A, except we're just in a different quadrant, and we're looking for this distance here. Of course, if this is 1 unit measure, this is going to be the square root of 2 over 2. But we know that this isn't 1 unit, it's 45 or 45 feet. So this is going to be 45 root 2 over 2. And we've already found that 45 root 2 over 2 is 31.82 feet. So for C, that's 31.82 feet. So let's try D. If the car the girls are riding has a central angle of 90 degrees from horizontal when the wheel stops, how far from where the passengers get on the wheel will the marshmallow land? So here's 90 degrees right at the top. And of course, if they drop the marshmallow, it looks like it's going to land right on top of their heads. So the distance is going to be 0 feet, or 0. So here, other than coming up with the decimal equivalents of some of these exact values, here we really don't need any computation. We just kind of do everything visually, which is important. We use the unit circle and a visual aid of the unit circle and our calculators in unison to come up with our solutions.